So this problem hinges on one of the special properties of triangles and squares and things like that. Namely, when you have 45, 45, 90 triangles, the sides opposite those angles have a ratio of x, x, and x times the square root of 2. So we're looking for the ratio of the perimeters of the innermost and outermost squares. The innermost is probably the easiest one to figure out, or excuse me, the outermost. The outermost, the perimeter is just 2, 2, 2, and 2, or 8. So outer perimeter is 8. The inner one's going to be a little trickier. So if one of these full sides is 2, then each one of these is 1. So then we have an isosceles triangle with a 90-degree angle in one corner, and therefore that's where the 45, 45, 90 triangle business comes in. If each of these is a length of 1, the diagonal is going to be 1 times the square root of 2. But that's the middle square. We don't need the middle square. We need the innermost square. So if this whole side is 1 times the square root of 2, then one of these half sides is the square root of 2 over 2. It's half that distance. So now we have a triangle here, square root of 2 over 2, square root of 2 over 2. Each of those is x. The diagonal of this triangle, which is yet another 45, 45, 90 triangle, each of the x's is the square root of 2 over 2. The diagonal is going to be that times the square root of 2. So square root of 2 over 2 times the square root of 2 one more time. These two guys cancel each other out, and we just get 2 over 2, which equals 1. So the sides of the inner square are each 1, and the inner perimeter is 4 times 1, or 4. And what we're being asked for is the innermost to the outermost as a fraction, or as a ratio. Inner over outer, and therefore the inner over outer, 4 over 8, is a ratio of 1 to 2. Answer choice A.